In the previous class we have discussed about the definition of autocorrelation function and formula for finding autocorrelation. In this class we are going to see about some properties. So the first one is how we are going to find the mean and variance of autocorrelation function. So this is given by, that is mean is given by E of x of t. So E of x of t is equal to limit modulus of tau tends to infinity r xx of tau. So this is our mean E of x of t, that is given by limit tau tends to infinity r xx of tau. So this is nothing but our autocorrelation function. Next, for finding the variance of autocorrelation function, you have to find E of x square of t. So E of x square of t is given by the formula r xx of 0. So by putting tau equal to 0, simply we get E of x square of t, and variance of x of t is given by variance of x of t is equal to E of x square of t minus E of x of t the whole square. So this is our variance. Next, to check whether the given function is given autocorrelation function is valid or not. So to check whether the given autocorrelation function is valid or not, simply put tau is equal to minus tau. So suppose our rxx of tau is equal to rxx of minus tau, then we can say that the given autocorrelation function is valid, otherwise it is not valid. So let us see some problems in this. So first problem, find the mean and variance of the autocorrelation function rxx of tau is equal to 25 plus 4 divided by 1 plus 6 tau square. So this is my question. So for finding mean and variance, first let us find E of x of t. So solution, E of x of t. So E of x of t is equal to, what is the formula I have written here? E of x of t is nothing but limit modulus of tau tends to infinity r xx of tau. So limit modulus of tau tends to infinity r xx of tau. So which is equal to limit modulus of tau tends to infinity. So rxx of tau is given in the question itself, that is 25 plus 4 divided by 1 plus 6 tau square. So which is equal to, when you put infinity to tau, what you get? So in the denominator, that is 4 divided by infinity. So this will become 0. So our answer is 25. Now let us find E of x square of t. So E of x square of t is equal to, so what is the formula for E of x square of t? That is rxx of 0. So simply put 0 in the place of tau. So rxx of 0. So that is nothing but, when you put tau is equal to 0 in this equation, you get 25 plus 4 divided by 1, that is 4. So 25 plus 4 is 29 is our E of x square of t. Next one is variance of x of t. So variance of x of t is given by the formula, what I have written there, E of x square of t minus E of x of t the whole square. So our E of x square of t is nothing but 29 minus E of x of t is nothing but 25. So that is E of x of t the whole square is nothing but 25. So 29 minus 25 is 4. So our variance of x of t is 4. So the solution is mean is equal to 25 and variance is equal to 4. So this is our answer. Suppose if they ask to check whether the autocorrelation function is function valid or not, you have to check Rxx of tau equal to Rxx of minus tau. That's all. Hope you understand. Thank you.